All right, so what's different about the ones that we're trying to find today? You are still looking for area. We've already found area underneath a curve before, but today we're trying to find the area that's caught between two curves. So when we find area underneath a curve, what kind of calculus symbol did we use to do that? What is it? The S thingy, the integral. All right, so hopefully it doesn't come as a surprise that we're going to use the integral symbol again today. So on this, when I want the shaded region, that's this yellow section right in here, I want to make sure that I set up an integral. Now the bounds for that integral, that tells me how far I want to go. What would the lower bound on this need to be? A. And then the upper bound. B. All right, now in looking at this, since you have two curves, what do you think you're going to need to do? You need to subtract. Which one needs to be first? F of x. Why f of x? Because it is on top. Notice if you trace the curve back, you do have f of x on top. So the upper function, f of x, goes first, minus the lower function in this case would be g of x. We're going to put that second. And then we are slicing up the x-axis there. Any questions? All right, next I asked, what if you wanted the area that's between f and g all the way from 0 to d? It's going to be weird now. All right, tell us.
Well, g goes on top after c, so I think you would do f of x minus g of x from 0 to c, and then after that, g of x minus f of x to c.
Perfect. All right, so hopefully you all are noticing, just like him, if your upper function and lower function switch, you're going to have to do two separate intervals. Intervals change, integrals change. So the first one, like he said, if we go from 0 to c, the function that's on top in that case is f of x. So we'll keep that minus g of x. After that, the next integral, it needs to pick up at c and go all the way to d, and on that one, g is now on top. So we'll put g of x first, minus f of x. And these are going to give us two different answers. What are we going to do with those two answers? Add them together. Very good. Any questions? Now, for those of you that are a little bit more visual, you seem to be taking to this fine, but really and truly, it is no different from what we were doing before when we did just one function. Because if I'm trying to find this area in here, if I find the area under f of x, that's going to include all of this area, the white and the yellow. Does that make sense? The fact that I'm subtracting off g of x back over there, that means this is where g of x starts. Okay? So if I take that area off, will you agree I'm going to be left with the yellow? So that is giving you essentially what you want. All right, now look at question number 2. And on this one, will you agree that looking at it as an upper function minus a lower function poses a problem? All right. The problem is that the upper and lower is both using the red function over here. That is not going to help us. So on this, the idea is if you just kind of turn your head, you can see it as an upper and lower. So students ask, well, which direction should I turn my head? Well, right now my head is up and down, okay? It's facing upward. So up is a positive direction. So I want to turn my head in a positive direction. So do you think positive would be to the left or to the right? All right, so if I turn it to the right, now can you look at it as an upper function and a lower function? Okay, so which one, if your head is up the correct way, which one is the upper function? What color? Green. So on this one, I'm going to need to think of it as the green function minus the red. now, a weird thing about this one is when you do have to turn your head's not in the normal direction. Instead of looking at this as slicing up the x-axis, will you agree we're slicing sideways now? All right, so what do you think is going to go out here? dy, very good, because we're slicing out the dy axis. All right, so over here on my bounds, you do need to make sure that you're finding the intersection here, that it needs to be the y values of intersection. And if I label these as, let's say, C and D, which one of those, is it C or D that would show up as the lower bound? The C is, because if you look on the y-axis, that C is a lower number going all the way up to the D. So from C to D along the y-axis. Okay?
So whenever you're getting your actual numbers to put on the integral, you would need to turn your head that way, right?
Yeah, you would need to kind of think of your head as being turned that way.
Well, I mean, like to get the D and the C. I mean, if you look at it that way,
Right. When you turn, okay, what essentially you're doing is looking at it as the inverse. So when I do the inverse, this is the positive x-axis. I'm having to make that the positive y-axis. So instead of rotating this way, you need to think of it as flipping, where this positive x-axis becomes the positive y-axis. So you're kind of flipping it that way. All right? All right, now I want you to look at question number 3. The entire test that I give you in chapter 6 is going to be all graphing calculator allowed. Because when we start looking next week at the free response questions, that typically there is one of the 6 questions modeled after chapter 6. It is, the ones I'll show you next week, nearly every one of them are a question number 1 from the exam. So if it's a question number 1 or question number 2, it's going to be on the calculator allowed section. So I need to make sure that you're very comfortable with the calculator. Meaning starting today, make sure you're using the calculator. Get comfortable with it. Just like going to get ready to take your driving test, you want to get lots of practice with that calculator. So I highly recommend that you go ahead and get this thing graphed. So go to y equals. Go to y equals. In y1, you're going to put in the x squared. And in y2, you can put in the square root of x. All right, now when you hit graph, depending upon what your calculator is set to, you may have a different window that you're looking at. The window that I'm looking at is a standard zoom in 6, and it's okay. I can see both of those functions there, but it's really kind of small where those 2 functions are overlapping. So I'm going to be able to see it a little bit better. It's also very common, guys, on the AP exam for them to give you a screenshot of these graphs so that they can make sure that you're looking at what they want you to see. So let's say, for instance, I had given you this screenshot. Well, when you're working the problem, you want to make sure that your graphing calculator has a screen that looks something like this. You can always modify the window accordingly. So I'm going to go to Window, and I'm going -10 to 10 on the window right now. I want it to look like this, so I notice the x goes -1, 2, 3, 4. So I'm going to change my x min to about -4, going over to +4. And what would be a good value to make my y minimum? I would say 3 would be good, -3-ish, 3 point something if you want. And then what would be a good at a y max? Positive what? Probably 3. All right, now when I hit graph, hopefully it's going to look closer to what I'm seeing there. Okay. Now that shows me what I really do want to find the area of, but making sure that you see what they want you to see. When they're talking about bounded by, they're talking about where they overlap. I'm seeing a little flower petal looking shape there. Do you all see it? Okay, so it's right in here is pretty much what we're trying to find the area of. Do y'all have to turn your head sideways, or can you just look at this one straight on? All right, so that tells me I'm going to keep dx out here. And these values that go in here, those are going to be the x values where those two graphs actually intersect. Now this one's nice in that you can probably guess what they are. What do they appear to be? 0 and 1. And you all are correct. If you're on the College Board AP exam, though, I don't want you to just assume that it's what it looks like on the graph. Because if it looks like 0 and 1, it may be 0.003 and 0.996. So to make sure that you know that that's what it is, I highly recommend that you use your calculator to double check the intersection. If you do second and trace, which option do I want to use? Intersect, so fine. And then it'll ask for the first curve, which is x squared. So you could have had 10 different functions in your calculator. So it's nice that it's asking you that. That is the first function. Square root of x. That's the other function that you want. And incidentally, left and right scrolls along those functions. If you do up and down, that switches to the other function. So just scroll here, and then whenever I get over, I want to get close to the point where I want it to find the intersection of. So I hit enter, and it tells me, sure enough, that is 1. And you can do it again to check the other one is 0. But 0 and 1 are correct on this one. All right, so now from here, I want to make sure that I put the upper function minus the lower function. And what would the upper function be this time? X squared, square root x. All right, so make sure. Let's see, the upper one here, that is the one going out to the side, so that should be square root x, meaning the lower function is x squared. And that's one you could do by hand, finding the antiderivative, and then plug in, or you can use the calculator to spit out the answer as well. All right, next I asked, what about the area that would be bounded from 0 to 3? Is that going to be the same answer? No. What do I need to do now? Two equations, two integrals. All right. Is this going to be part of my answer? All right, so I'll go ahead and recopy that. I know from 0 to 1, square root of x minus x squared. That's part of my answer. That's actually the green section right there. But I'm going to need to add to that another integral. And when I'm adding, I'm going, here's 1, 2, 3. So I'm actually looking at extending this graph out. I'm actually trying to find that area also. All right, what would the bounds be for that one? 1 to 3. And what's the upper function? X squared minus square root x. And add those two together, and that should give you your answer there. Any questions? All right, I'm going to be quiet. I want you all to look at number 4. And guys, on number 4, what is strange on this equation? Y is being squared. Okay? When you go to put that in your calculator, do you have an issue? All right, you have a y equals to put equations in. You don't have an x equals. You need an x equals if you're going to put this one in the calculator easily. All right? Do you all know what x equals y squared would graph as? It would be square root of x, but that's only half of it. All right, will you agree that's a sideways parabola? Isn't it opening to the right? Isn't the other one also a sideways parabola opening to the right? Okay, so if you've got two sideways parabolas opening to the right, I want you to consider that for just a second, guys. I've got one of them, and this is just a quick, ugly sketch here, and here's the other one. Will you agree the area we want is down here? Okay. Well, that's groovy. What would you have to do to set this one up? Say it louder, John. and minus if you want to do it that way. What did we do on example 2? You turned your head sideways, and didn't we have to set that one up with dy? Okay. Well, I would suspect most of you don't like doing that. Am I correct? All right, so imagine this. If I took this picture right here and did this, has the area changed? Okay, so if I were to change the equation to where it was actually this, the area has not changed at all, has it? Wouldn't that be an easier one to set up if it was like this? Okay, so how can I change those equations to where I would have parabolas that are opening up instead of opening sideways? Switch the x and y. And what is that called? Inverse. So that's what we're going to do on these. We're going to use inverses. And that's exactly what I did. For the very first one right there, the 2y squared equals x plus 4, I switched the x's and y's. So I made it 2x squared equals y plus 4. And if you want to do that on one of them, you need to do it on the other. So that means x squared is going to equal y. I can put those in the calculator because I've got y by itself on the second one. The first one, y is going to be a 2x squared minus 4. So each of those I put in the calculator. Okay, hope it's quick. All right, now I want you all to see if you can set that one up for me. Guys, when I set it up as the inverses, do you notice you don't have to turn your head sideways anymore? It's acceptable to redefine the problem like this. Even on a college board test, if you redefine it where they can see that these are the equations that you're using to solve this problem, you can go ahead and set up your integrals and you don't have to use the y's anymore. You can use the x. So I'll put the dx here, which means I've got to find the x values where these graphs are intersecting. So hopefully you all found those for me. Did you find what the one over here on the left is? -2, very good. And on the right, 2. All right, so now when I'm looking at that, I still need the upper function minus the lower function. What is the upper function going to be? X squared, so that one goes first. Minus the lower function is 2x squared minus 4. All right, does anybody notice anything? All right, you could combine the x squares, but notice I said minus and I had this line here. Didn't I put more than one thing on this line? All right, so you are going to have to think of that as being in parentheses. All right, so that would be the same thing as having from -2 to 2 of x squared minus 2x squared is a -x squared, and then plus 4 would be the simplified answer, or simplified version to get the final answer there. Any questions? All right, I want you to look at number 5 and see if you can get that one set up. Use your calculator to graph it first. Guys, when you graphed it, hopefully you have something that looks about like this. In which case, you need to be able to determine which portion of that is the area that's bounded by the 3 functions. What would you all describe that as, the shape? Kind of a triangle? With a parabola side over there. All right, last period I had somebody that described it as a sailboat, like a sail on a sailboat. Can y'all see that? It is this section right over here. It does kind of look like a triangle on this side, but then this is kind of curved. It looked kind of like a sailboat sail too. Make sense? Now when you have more than 2 functions, you have an even greater chance of the upper and lower function changing, or maybe just one of them will change. Anytime one or both of them change, you have to set up a different integral. So looking at this, is your upper function going to remain the same? The entire time for this cell here, what is the upper function? X plus 6. That is that line, the x plus 6 line. So that is always the upper function. All right, what about the lower function? Is it the same? All right, the negative 0.5x, Drew thinks that's the lower function. What about y'all? Is it always the lower function? Okay, it's the lower function up to where? 0. Very good. At 0, though, notice it does change. What becomes the lower function after 0? X to the third. Okay, so we have a change in the lower function, which means we do have to set up two integrals. So the first integral, I am going to need to know where this green intersection point is, because that's where that integral is going to begin. I'll let somebody figure out where that is for me. It's going to stop, though, at 0. Somebody got where that intersected? Negative 4. Okay, so negative 4 to 0. Now, the upper function, you all told me, was always x plus 6. So I'm going to plug that in. Minus the lower function on this one would be what? Negative 0.5, so negative 1/2 x. All right, will you agree that we can make that plus a positive? Okay. All right, and then we got dx. All right, that's only part of my answer. The other part of my answer I'm going to need to add, picking up, where do I start this integral? 0, and where do I stop it? At 2. Is that where this intersects over here? Okay, hopefully y'all found that correctly. All right, upper function, you again always told me that x plus 6 was on the top, minus what's on the bottom for this one? X to the third, there you go. Got dx. So you get both of those, add them together, and that gives you your final answer then. Any questions? All right, I need you to look at number 6 for me. What do y'all notice about the equations for number 6? Right, she's saying she wants to use the inverses, right? You've got an x equals in both situations, so this one really would be easier if we use the inverses, and that's exactly what I did. So hopefully you go ahead and put that in your calculator. I can get the thing to move the wrong way. There we go. When we put them in the calculator, now I have a line and I have an upside down parabola as opposed to a parabola opening to the left and the lines. We're using inverses. I'll set this up. I'm going to have dx down here because I'm using the inverses. And the equations are y equals 3 minus x squared and y equals x plus 1. Now, does your upper and lower function change? Well, first of all, where would I shade on this? Kind of like a little half ellipse, or it's kind of a section of a football looking shape. Does that make sense? Okay. All right, you've got the upside down parabola and you've got the line. Which one is on top? The parabola. Is it always on top? All right, what's on the bottom? The line. Always on bottom? Then you only need one integral. So we need the upper minus the lower And here, I've got to have the x bounds where those are intersecting. So I need to know this x value and this x value. What's the one over here on the left? -2. Let's see if I can make that look a little better. All right, and what is the one over here on the right? 1. All right, upper function on this one would be 3 minus x squared. And then the lower one, x plus 1. And what do I need for it? You need parentheses around it. There we go. So if you wanted to clean that one up, you'd have from -2 to 1. You'd have 3 minus 1 would give you a 2. Minus x squared minus x. Plug that in the calculator and it'll spit it out. You can also do that one by hand.